All right, last set of problems we're going to do here is some half-angle identities with tangent. So what I did is I took the three formulas, I slid them down, recopied my trig charts. This way I'm not bouncing back and forth on the page. I would actually recommend it. I have a bunch of them sitting around my desk at school and my desk at home. I actually write them down on a piece of paper and just keep them handy so I can reference the paper as opposed to bouncing around all over the electronics. But that's what makes sense for me. All right, so problem number 5 here, tangent of 9 pi over 8. Where is it? So if I were to graph it, right, I would have 8 over 8 would get me here. Whoops, let's try that again. 8 over 8 would get me to 1/2 circle on pi. And then 9 over 8 would get me just a little bit further into Q3. Quadrant 3, tangent is positive. So I know that this is going to be positive, and my tangent formula is sitting right over here. It's kind of the most complicated one, but it's based off of sine divided by cosine. It's the same idea. And so we're going to do the square root of 1 minus cosine over 1 plus cosine. I'm going to fill that in. So I'm going to take 9 pi over 8, which is the half angle, and I'm going to double it to find the angle that I'm working with on the unit circle. So if I take 9 pi over 8 times 2, that's going to get me 9 pi over 4 and 9 pi over 4. Where is 9 pi over 4? And the answer is, if I were to graph it, so we're dealing with a denominator of 4, so it would be 4 over 4, 8 over 4, and a little bit further actually puts you into quadrant 1 with a reference angle of pi over 4. Okay, so 9 pi over 4 is actually coterminal to pi over 4, so it's kind of nice. So this is going to turn into the square root of 1 minus. Now the cosine of pi over 4 is root 2 over 2. So root 2 over 2 all over 1 plus root 2 over 2. Okay. I don't need the identities anymore. I don't need my trig chart anymore. I just need to simplify this. And trust me, there is plenty to simplify there. So I'm going to zoom in, but I'm also going to make sure I have space because, well, you guys know I write huge. First thing I want to do is get rid of the complex fractions. So I'm going to take numerator and denominator, and I'm going to multiply both of them by 2. So this is going to turn into the square root of 2 minus root 2 over 2 plus root 2. No, those don't cancel. All right, let's just, no. All right, don't do it. However, I do want to rationalize my function here. And right now I have radicals on top of radicals within radicals. So I want to see if I can kind of simplify some of the stuff. And I'm going to start by trying to get rid of the radical inside this denominator here. So I have the expression 2 plus root 2. To get rid of a 2 plus root 2, I'm going to multiply top and bottom by its conjugate, 2 minus root 2. And basically, I'm going to distribute numerator and denominator. So the square root is going to stay, like this big square root that's around everything, that's still going to stay. We'll deal with it later. And basically, I'm going to distribute the numerator, distribute the denominator, and see what happens. So let's see, I've got 4 minus 2 root 2 minus 2 root 2 plus. Now, this one you want to be careful about. So negative times a negative is the positive. Root 2 times root 2 is root 4, but the square root of 4 is 2. All right, denominator, I'm going to do the same thing, but remembering that one's positive and one's negative. So 2 times 2 is 4. Minus 2 root 2 plus 2 root 2. Now this one I've got, let's see, positive root 2 and a negative root 2. So it's going to be negative root 4, so negative 2. I know, lots of stuff going on with these problems. Things that you should notice, we've got in the denominator a negative 2 root 2 and a positive 2 root 2. Wave bye-bye, they gone. All right. Numerator, collect your like terms. So we've got 4 plus 2 is 6. I'll put the big root in a second. And I've got negative 2 root 2 and another negative 2 root 2. They do not cancel. All right, they become negative 4 root 2. All over 4 minus 2 is 2. And I told you I'm going to put that big square root in there, and I am going to. I promise we got one more step. I promise, that's it. All right, the last piece here is this 2 can divide into that 6, and this 2 can also divide into that 4 root 2. So I want to do that. So this is going to become the square root of the quantity 3 minus 2 root 2, and the denominator is 1, so I don't have to write it, and I'm too lazy to write it, so I'm not going to. So the exact value of the tangent of 9 pi over 8 is the square root of the quantity 3 minus 2 root 2. So yes, I still have radicals within radicals, but I do not have a denominator anymore because I rationalized it out. So yes, you need to be able to rationalize out your denominators. All right, that's problem number 5. Let's go ahead and slide on over to problem number 6. All right, problem number 6, we've got pi over 12. Pi over 12 is located in quadrant 1, which means that when I do this tangent, I'm going to pull the positive part of the plus minus. So this is going to equal plus 1 minus the cosine, and then 1 plus the cosine. Now, what's going to go with that cosine? I'm going to take my original pi over 12, which is x over 2. I'm going to double it, and that will find me the x value that goes on the unit circle. In this case, it's going to be pi over 6. Now, pi over 6 conveniently is already a reference angle for us, right? We've got this whole pi over 6 thing going on here, so it's kind of nice to just work with that. So this is going to be the square root of 1 minus cosine of pi over 6 is root 3 over 2. So root 3 over 2, and then 1 plus root 3 over 2. Now this is where I'm going to pause here for a second because I no longer need the identities. I don't need the trig chart. I just need to use my ability to simplify expressions to simplify the expression. All right, so I'm going to start by multiplying numerator and denominator times 2. It will remove the complex part of the fractions. So 2 minus root 3 over 2 plus root 3. Okay, and basically the same idea that I did in the last problem is what I'm going to do here. I'm going to use the conjugate of the denominator. So 2 minus root 3 is the conjugate. It's the same expression, just one's positive, one's negative. Those are conjugates to each other. And of course, what you do to the denominator, you have to do to the numerator. We've got to distribute. All right. So 4 minus 2 root 3 minus 2 root 3 minus, nope, I lied, it's going to be a plus. Negative times negative is a positive. Root 3 times root 3 just becomes 3. All over, and I'm going to do the same thing to the denominator. So 4 minus 2 root 3 plus, that's a horrible 2, plus 2 root 3. Now I've got positive root 3 and negative root 3, so that's going to become negative 3. And this whole thing, do not lose that radical, right? That big radical that we had stays. But now let's go ahead and collect up some stuff here. In the denominator, we've got negative 2 root 3 and a positive 2 root 3. Wave bye-bye. That's part of the reason we use the conjugate is so that you should not have any radicals left in the denominator. Okay. Numerator-wise, we've got, let's see, 4 here plus 3, so 7 minus 4 root 3. Those two terms here combine. And then in the denominator, you have 4 minus 3, which is 1. Dividing by 1 does absolutely nothing. So I don't even need to write it. It's just the square root of the quantity 7 minus 4 root 3. And that is the exact value for the tangent of pi over 12. All right, we've got a bunch of examples for 2 sine, 2 cosine, 2 tangent values. Please let me know if you have any questions or concerns about these. You'll get a chance to do some practice with them